you look at it, and they give me a function down here, which I know is too small to read, huh? Well, maybe. Guys in the front, Christina could see that, huh? That's about it. No way, Lauren, right? But you have your book, and that little p of x, what's it stand for? That's the price function. We've had that quite a bit in this class, right? Am I trying to maximize or minimize the price function? No. Matter of fact, when I do these problems, guys, have I even read it yet? No. I go right to the question. And I say, oh, part A, what's it say? Determine the revenue function for the fleece, boot, and backpack combos. Okay. So that's what they gave me was a price function, right? And so part A says, let's find the revenue function. We've done this a few times. You guys know the formula for revenue? Sure. The number sold times the price, or x times p of x. So because they gave me the price function, by the way, how's the size, Lauren? Can you see that? Okay. So x times, and we have, well, 0.14x squared minus 15.52x plus 561.21, and they tell me that x can be anything between 5 and 55, right? That is my closed interval. If we wrote it in interval notation, it would be like this, 5, 55. Now I'm making it look more like the problems you did without any applications, okay? Actually, this is a lot like a test question that you had. I said find the revenue function and simplify it. I remember that. Another one I said another one I had a profit function and simplify it. I think that's what it was. But for the revenue, I have this. Why don't I rewrite it? R of x equals, so let's write 0.14x cubed minus 15.52x squared plus 561.21x. That's just a simpler form, and it's going to be easier when I take the derivative. Okay? So part B, I'll do in blue here. B says determine the maximum revenue. Well, we have the revenue function. You just have to figure out where it reaches a maximum. And what the theorem said was it's either at critical values or endpoints. That was what I tried to get across last time. Hey, raise your hand if that actually means something to you. Critical values or endpoints. So what's a critical value? Where what's undefined or equals 0? The derivative, right? We have to take the derivative in order to find the critical values. And the endpoints I have, those are 5 and 55. All right? So if I want to find the maximum revenue, I think the next step I'm going to do is I'm going to find the derivative. So let's do r prime of x would be 0.42x squared. That's 3 times 14 is 42. Minus, this would be 31.04x, because that's what 2 times 15.52 is, plus 561.21. Okay? That is r prime of x. Now, if I want to find the critical values, I want to figure out, is this thing ever undefined, or does it ever equal 0? Well, I would say you could set it equal to 0 and you can solve. Now, how do I want to solve that? Well, I know I could factor in theory or quadratic formula, but this is ugly, right?
Yes, it's really, really tough.
And we have a calculator. You want to use your technology to help. So I'm going to go ahead and graph a few things here. Okay? There's my calculator. What I'm going to graph is I'm going to graph the derivative, not the function. I have the revenue function here, but I'm going to actually graph the derivative. So the derivative, let me go to the y equals screen, and let me clear this one out, because I'm going to put in this function. It's 0.42 x squared right? And then I have minus 31.04 x plus 561.21. And I'd really like to know where that function is 0. Enter. So there's the derivative in the calculator. You guys have it in your calculator? Okay. So now, let's see. I better get a good window or I won't be able to see it. Oh, it told me what to do for x min and x max, right? Let's go from 5 to 55. Okay. It doesn't tell me what to do for y min or y max. Well, you know what? I'm just going to leave it. From negative 10 to 10. That's probably no good, but let's see what happens. Graph. Oh, actually, it wasn't too bad. This is a graph of what? A parabola, and this is the derivative. You guys with me? So if I have to figure out where the derivative is 0, well, right there and right there. Those are the critical values. Now, to find those critical values, you can trace if you want. And if you move along the x-axis, you get pretty close. So what's that x value right there? Well, yeah, 31.54. That's pretty close to a critical value. Okay. From the quadratic formula? So you did the quadratic formula. Let's get the values you got, because that's actually really good work. So x equals 31.54, and Matt, you got something else? 42.36. I want to show you how to come up with that 42.36 using the calculator. If I hit second trace, here's the calculate menu. Do you see choice 2 here? 0. That means find an x-intercept. Find a place where the function equals 0. Now it says left bound, and it's going to ask you right bound. Because basically I want to figure out, well, between where and where. Let's say between 25. Oh, that's no good. Well, it's okay. If I go between 25 and 35, and then it says guess, I'll get that one I was just talking about. But if I want to get the other one, calculate a 0, and again, give it a left bound. Let's say between 35 and 45, maybe. Maybe that'll get me the other one. Somewhere between there, I don't really have a guess. There it is. The other 0 is 42.36. You guys with me? There were problems last night, or over the weekend that you worked on, that you actually had no way to do it algebraically. You had to use a calculator or a computer. Okay? Sometimes that happens. There's plenty of problems that I have no way of doing algebraically. And actually, a good question is, how did the computer figure out what the 0 was? If you want that, take my other calculus class. Okay, Calc 1, 5 credit hours. Okay, we could show you that. So, let's see. We have the two x values. So now it's a matter of, let's test the function, well, at those values and also at some other values. Okay? So in order to do that, I'm going to go to the y equals screen, and I'm going to type in the function now. I could have done it earlier. Let's leave the derivative there in case we want it later. But down here in y2, let me type the revenue function. So let's see, 0.14. Oh, wait a minute. I got a better well, we'll do it. 0.14 x cubed, so x caret 3 minus 15.52 x squared, and then plus 561.21 x. Now, if we graph this, we're not going to see anything, are we? Because it's way off the map. Where is this revenue function? Well, it's way up there, right? Like, if you put in a 0, oh, wait a minute. If you put in a 0, you're at 0. So it actually hits 0, 0, but then just shoots up. Right? Anyways. And it says that the function really only goes from 5 to 55. You can actually hit the trace button. Okay? And here's y1, but if I hit the up or down arrow, I can select y2, and it'll give me the y value for the revenue function. Okay? So, let me go ahead and do this now. We're supposed to find, let's see, the maximum revenue. And I want to do it just like we did those problems without the applications. So I'm going to list some x values, and I'm going to tell you what r of x equals. And now I have to think about what x values I want. Well, I want critical values. There's 2 of those. So we'll try 31.54. We'll try 42.36. But we'll also try the endpoints. We'll try 5 and 55. And one of those 4 has to be the maximum value. Okay? So now it's just a matter of, substitute in, see what we get. Let me work it out. I'll hit second, calculate a value. And let me type in 31.54. I got, oh wait, no, that's the derivative, right? Because it says that's about 0. Let me hit the up arrow, or down arrow, there. So the value is 6654.
How would you know to hit the up button?
Well, because I put it in y2, right? It starts out showing you what y1 is, but if you hit the down or up, it'll select a different function for the same x value. You get what I'm saying? So that's what 31.54 is. Let me try second calculate a value, and let me type in 42.36. Enter. Oh, again, that's the derivative. I want the function. Where are we? 6565. Boy, those revenue values are not too far away from each other, are they? Let me throw a 5 in there. So let me calculate a value, and let me throw a 5 in there. Now, is that y1 or y2 it's looking at? Okay, that's y1. We want y2, which is the actual function. Okay, so there we have 2435, 55, right? Maybe I'll just round. Know what it says? And then let me get the last one. Let me calculate the function for x equals 55. Well, that's the derivative. So let's go to the function. There we go. 7211.05. So 7211. All right, guys. So what is the maximum revenue? $7,211. There's my answer for part B. Part C. Determine the demand that maximizes revenue. What would you guys say? We have to use the price function. So when I say demand, are we talking about the input of the price function or the output of the price function? We want to know what X is. So what would the demand be? The demand should be 55 what? Combos per day. To maximize the revenue. And then D, that's all I had to do. Yep. Yep.
I had P prime of X.
What's that?
I had done P prime of X.
P prime of X?
Yeah. So, and then I did like an XY chart with 5 and 55.
Yeah.
What was that doing?
I don't know. P prime, I don't really know what that does.
Okay.
I mean, you're finding the rate of change of price. Okay? So we didn't need that. But for part D, we do have a little bit of work to do. What's part D ask? See, part D is what you really control, isn't it? It says determine the price. Can you determine the demand? Well, not directly, right? But if you want more demand, you're going to lower your price, and if you want higher demand, you're going to, or less demand, then you'd raise the price. Okay. So right, let's do that. Let's compute P of 55 here. And let's figure out exactly what that is. And actually, I felt like I just did that. Oh no, I computed R of 55. So if I go back to what I had, yeah, there's R of 55. But if I had hit the up arrow, or maybe not hit the up arrow, isn't this P of 55 right here? No. This is R prime of 55. Take that back. We never did P of 55. All right, let's compute it. P of 55 would be, well, 0.14 times 55 squared minus 15.52 times 55 plus 561.21. I have to compute what that is, and I'll get the price. All right, so I'm going to pause while I punch that into the calculator. And so we calculate all that, and we get...
No, you don't want to multiply that 55.
Oh, you're right, because the price function doesn't have a 55. Thank you. So let's delete all that, right? So there it is, right? Enter. So the price is $131 and 11 cents. How about that? So that's the price. Okay. So that's what we ought to charge if we want to maximize the revenue. But, you know, it's interesting. Sometimes the graph of the revenue function will do this kind of thing, and sometimes it'll do this kind of thing. Okay? I think the revenue function looks like this. If you look at my revenue function, it starts out, well, around, here's the point, 524.35, right? And then it goes up, goes up, goes up, until it gets to, say, 31.54. That's when the derivative is 0. That's a critical value. And it'll be $6,654 at that point of revenue. But then it comes back down, and so you'd have a minimum value, a relative minimum, here. 42.36, comma, 65.65. So, it's funny. I could change the problem. If I changed it in the following way, suppose I said, hey guys, we're only going to go from 5 up to 40 for my closed interval. Well, then your graph would only go to like here, right? And then the maximum value you would get at the critical point. Does that make sense to people? But our problem didn't go to 40, it went to 55. And so you really had to keep going. And so here, the maximum value you're going to get is not a critical value, it's an end value, an endpoint. So I hope that helps a little bit. I don't know. All right, so I'm done with 38. I'm going to flip the page and try 44 with you. So 44, part A. Well, you guys should be able to do that because 44 part A says determine the weekly revenue. And I understand how to do that, all right? And then in part B, we're going to maximize the weekly revenue. So I understand basically what I'm going to do. Kind of similar to the last problem. I'm going to find a function for revenue, and then I'm going to take derivative, find critical values, etc. So maybe I should pause for a minute and see what you guys can do with this. All right? Why don't we all work together on this a little bit, all right? Instead of me just doing it like I just did. See if you can work with someone near you, and at least see if you agree on part A. And if we get that, then we're going to try the process for part B. Okay?
So that's how the back of the book they found the zero. So that's where I was thrown off. That makes sense then.
Yeah. This one is more complicated. I see what you're saying. I don't think it's that simple, right? Let's see. We are confident we can sell 3,000 for $10 each. But if we reduce the price, that'll increase the weekly sales by 180.
I think
This is pretty cool. All right. Let's show you what we got on this. So, even part A is tricky here compared to some of the other ones, you know? I mean, it says the marketing department is confident that they can sell a certain amount. We know that the revenue function is X times P of X, right? But did they tell you what the price function is? They did? What'd they say? Well, they said if they're $10 each, they could sell 3,000, right? But they also said they might change the price. Do you guys see that? So, I mean, in order to use this formula, x times p of x, we really have to know what the price function is.